So today we'll talk about chapter 16, which is about scientific notations and engineering notation. So remember the last class we talked about the unit of measures, right? Where we learned about different units which we use in the engineering discussions. There are plenty of other units as well, but we try to cover the major ones. I think this is the right time to talk about the scientific notations, so that's why we pretty much jump up to chapter 16 from chapter 7. But don't forget that we don't follow the chapter in sequence, so we pretty much come back to the previous chapters again. Okay. So, first of all, in the scientific discussion, as you know that we have 10 digits, but out of 10 we have 9 digits which are assumed significant except 0, pretty much all the ones except 0, meaning 1 to 9. Most of the cases 0 we use as a placeholder. So 0 does not contribute anything to the number, but still 0 has a significance because you cannot write a number without 0. For an example, let's say you have a number 109. Now in the middle you have a 0 which doesn't make any contribution, but without 0 the number becomes 19, right? That's a huge difference. So 0 is mostly the placeholder, but which still has a value, I'm saying significance. And 0 at the end of a number and to the right of a decimal number are significant. For an example, as you can see here, 0 are not significant if it is appearing in front of zeros expected as above. Zeros are not significant if it appearing at the end of a non-zero numbers. Now let's see what it is saying using some example. Now for an example, okay, we'll look at the example, but before we go to the example, let's look at a couple of things about the exponent. Anything can have exponent in scientific discussion, right? So for an example, anything have exponent 1 is exactly the same thing. Let's say the 10 to the power 1 is 10, 5 to the power 1 is 5, 100 to the power 1 is 100. So, but anything to the power 0, no matter what it is always 1. So for an example, 10 to the power 0 is 1, equally 3 to the power 0 is 1, 100 to the power 0 is also 1, million to the power 0 is also 1. No matter what the number is, if the exponent is 0, the result is going to be 1. Okay, and also the power has a different meaning. If you have a power 3, that means you are basically multiplying the same thing 3 times. 10 to the power 3 means you multiply 10 3 times, 10 to the power 5 means you multiply 10 5 times, right? So so again you get, so the way we have the power is, the power can be positive, power can be negative as well, right? So if the power is positive, power means they are larger than, they are 1 and larger. Negative power means what? They are lesser than 1, right? Even not 0, because 0 is different, but except 0, all the other ones which is less than 0 are negative numbers. Now for an example, in here, let's say this is what, 57.6. So you can think the number like this. So every position has a weight, right? Since this is a decimal number, now let's say the weight of the 7 is, everything can be defined in terms of 10 because this is decimal, meaning 10 base number system, right? 7 is what? 7 times 10 to the power 0. Similarly, the more you go to the left side, the power will be raised by 1 every time. So if you go to the 5, it will be 5 times 10 to the power 1. But similarly, if you go to the right direction, the power will be getting increased every time by 1. So if you go beyond decimal point, for an example, the first digit is 6, that will be 6 times 10 to the power negative 1. Now how the negative 1 works? Negative 1 means you are basically, instead of multiplying, you are pretty much like dividing the number by 10 power. So it's pretty much, it's basically 10 divided by 6. Or you can think like this, that for every power you'll be moving the decimal point 1 positions to your left. So here in the 6, decimal point is right after the 6. since the power is 1, you move it to the one position to the left. Okay. If the power is -2, then you will be moving the decimal point 2 positions to the left, right? Okay, so here are some examples that rules for writing the numbers in scientific notation. Now remember, in the scientific discussion, what happens is sometimes you have a number, you might have numbers which are extremely longer. Okay, so what we usually do is, instead of writing the number, the whole number as that long, we use some kind of power, power of 10 for an example, to make it shorter. Okay, so what in general we do is we move the decimal point to follow the first significant figure. This will yield a number between 1 and 10, and then count the number of places the decimal position is moved. Now you may have to move to the left, you may have to move to the right, it depends on the number. Then we drop all the zeros that are no longer used as placeholder, because there might be some zeros, we'll show you how. And then we write the number with the adjusted decimal place and show the multiplication by 10 raised to the power. Now for an example here, okay. Now let's say what we do is, the decimal point is here, right after this 0. To make it a scientific notation number, what we do is we move the decimal place from here to just right after the first significant digit from the left side. Now the first significant digit is this one, right, the 3 at the left side. So you move it just right after the 3. Now once we move it, this number becomes 3.3, right? Because none of the zeros you have right after the last 3 doesn't make any difference. So we can avoid those, but before we avoid those, we just write 3.3 and we count how many times we move the decimal point. Now let's count. Decimal point was here at the beginning, right? How many positions we moved? 1, 2, 3, 4, 5, right? So you move the decimal place 5 positions to the left. So that means we have to multiply it by 10 to the power 5. Now remember, if you move to the left, power will be positive. In some cases you might have to move to the right. For an example here, it's another example. Now what you need to do is you have to move the decimal point right after the first significant digit. Okay. Now the first significant digit here is what? 4. Remember we mentioned the significant digits means 1 to 9, not zeros. So right first significant digit is going to be 4 here. So how many positions you will have to move the decimal point? Let's count it. 1, 2, 3, 4, 5, 6, 7. And then once we move it to 7, this number becomes 4.7, right? Now we write it as 4.7, and since we move the decimal point 7 positions, the power is going to be 10 to the -7. The reason is negative because you are moving to the right. If you move to the right, that's negative. Move to the left, the power will be positive. Okay. Similarly, we have some other examples here, but in some cases you don't have to move the decimal point. For an example here, because your decimal point is just right after 9, and 9 is the only digit here, which is the first digit as well. So you don't have to move the decimal point, but still you can write the same number as a scientific notation, where you probably just write 10 to the power 0 because you have not moved the decimal point anywhere, right? I'm saying not to the right, not to the left, so that means it will be 0. And that's also safe because anything to the power 0 is 1, so that doesn't make any difference because it's just how you are writing the number as a scientific notation, but you are not changing anything, right? No value. Now let's see whether we understand some of this example. So what we will do is we'll give you a number and we'll just tell you to write the same number as the proper scientific notation. Proper means just right after the first significant digit, right? Your decimal point will place, right? So what will be the proper one? So your decimal point has to be just right after the 3. So the number will become 3.42 times. How many positions you moved? Decimal point position place was here, right? You moved here 1, 2, 3, 4 positions to the left. So it will be 3.42 times 10 to the power 4. The right answer is B. Any question? Yes, yeah. It will be always just right after the first digit from the left side. I'm saying first digit means first significant digit. And the significant digit means anything from 1 to 9. Okay, not zeros. Let's look at another example here. What will be the right answer? It will be still 3.42 times 10 to the power negative 4, right? Because you are moving from here to the right. So the right answer is going to be C. Let's look at another example. 764. How you are going to write it as scientific notation? So your decimal point is right after 4 and you will move it to right after 7. You are moving to the left, so the power will be positive. 7.64 times 10 square. Right answer is A, right? Another example, 3.35. So you'll be writing 3.5 times 10 to the power 1. Because you move it to 1 positions to the left. Right answer is D. Any question? Right answer is D. Another example. $22,000. So it will be 2.2, and you move the decimal point 4 positions to the left, right? Because decimal point is right after the last 0. So it will be 2.2 times 10 to the power 4. Right answer is B, right? Can we convert this? .73 times 10 to the power negative 3, because we moved the decimal point 3 positions to the right. So power is negative since we moved right. Another example here. 2.04. So you move the decimal point just 1 positions to the right. So the power is going to be negative 1. So the right answer is C. Another example here. This is the last one. 2.39. You don't have to move the decimal point at all, right? So, but you still want to write it as a scientific notation. So the power of 10 will be 0. So the right answer is D. I'm sorry, right answer is B. Right? Okay, so we have seen a couple of examples that how you basically adjust the decimal scientific notations, but in some cases you might see that scientific notations are written, but the decimal point is not at the right place. So far, whatever we have seen, those are called proper scientific notation, where the decimal point is placed just right after the first significant digit. But you will see some cases we probably have a scientific notation where the decimal point is not at the right place. Now in those cases we try to make it proper. That means what? We have a scientific number with scientific notation, but the decimal point is not at the right place. So we have to move the decimal place to the right place. It may be right, I'm saying you might have to move it to right or left, depends, right? So, and then, excuse me, based on how you are moving the decimal place, you'll have to adjust the exponent of 10, right? Because there will be already an exponent, you have to adjust it. Now, so let's look at here and see how you adjust it. If the decimal number gets smaller, the exponent gets larger. That's probably another way of thinking, okay? If the number is getting smaller, exponent will be larger. That means what? You will increase the exponent by that many positions. Or if the number is getting larger, exponent will be getting smaller. Now look at the examples here. For an example, let's say this is a notation, scientific notation, but look at the decimal point here. It's not in the right place because the decimal point should be right after 3. So, but you have to move 3 positions to the right. But the thing is, after you move it to the right, guess what? Is the number getting increased or the number is getting decreased itself? Don't look at the exponent part, because the number is right now 0.00308, and if you move it to the 3 positions right, it will become 3.08, which is getting larger, right? That means what? Your exponent is going to be smaller. How many positions? 3, since you move the decimal point 3 positions to the right. So what we did is, look at the exponent. Your exponent was -7, and we subtracted 3. That becomes -10. The reason we subtracted, because remember, we have to make it smaller, right? Similarly here, the decimal point is right after 0, last 0, and we have to move it to right after 2. So we are decreasing the number, right? Because the number is 27,000, and then after you do this, number will become only 2.7. It's getting decreased. So the exponent will get increased. How many positions? 4 positions, right? So that's why we add the exponent. So pretty much we add 4 plus 4 with the -7. That makes it -3. So you can also do it using the calculator. So, but it depends that what sort of calculator you are using. The calculator gives you both, meaning whatever the number you are having, if it is in scientific notation, you can get as regular number, right? So what you need to do is, you first have to write the number as decimal, okay? And then most of the cases, I think most of the calculator has EXP or EE. It depends on what calculator you are using. See, we are not talking about the TI calculators, because TI calculators are a little bit advanced ones, so it has more features. But in the basic ones, you will have either EXP or EE. If you have a calculator right now, you can check which might be the option you have to see whether you can use the calculator to work with our quiz question in pause. It may be an EXP or EE. Let's see how we adjust the improper scientific notation to proper one. So here are some examples. 23 times 10 to the 3. So if you adjust it, you have to move it to 1 positions to the left. So the number is getting decreased. Power will be increased, right? Yeah, power will be increased. So it will be 10 to the 4. So the right answer is D. Another example here. 45.8 times 10 to the -5. You move the decimal positions, 1 positions to the left, right? So it will be 4.58. It's getting decreased. So the power will be increased, right? Increased by what? By 1. So the power will be 10 to the negative 5 plus 1. So it will be 10 to the negative 4. So right answer is first one, A. Right? Okay, so what would be the right answer here? So if you move, you have to move it 2 positions to the right, right? This is 5.61 times 10 to the 4. So if you move it 2 positions to the right, number is getting increased. So the power will be subtracted by 2. So the power will be 4 minus 2 is 2. So the right answer is A.
So why would that be negative? Since it's on the
Because the number is getting increased, right? If the number is getting increased.
started out as 4, wouldn't that, because it got the power as 10-4, that wouldn't normally be 10 negative 4.
No. That was given to you, right?
Yeah. Okay, so just whatever.
Yeah. Whatever is given. Yeah. We are not looking at how it is given. So it's, it is already given, right? So the right answer is A here. So you have to, we'll move the decimal point right after 9, right? 2 positions to the right, number will be increased, so the power will be decreased, so it will be 10 to the negative 4. It's already negative 2, you subtract 2. So the right answer is 9.75 times 10 to the negative 4. So the right answer is C. Okay, so in some cases you may have to convert the scientific notation into the regular number. The question is, how do you do it? So all you need to do is you have to add some zeros either to the right or left. It depends on how the decimal point will be moving. So for an example, let's say if your power is positive, your decimal point will be moving to the right, and you will have to assume a lot of zeros in the right side and then move the decimal point 5 positions to the right. Okay, so for an example, if the number is 3.3 10 to the power 5 as it is given there, so you just assume 3.3 and then after 3 we assume there are zeros, and then we move the decimal point 5 positions to the right. 1, 2, 3, 4, 5, right? So that this is going to be the number, and we delete the. Okay. Similarly, if the power is negative, you move the decimal point that many positions to the left. For an example, this one, the power is negative, right? So we assume there are plenty of zeros in the left side, and then we move the decimal point to the left side. So that means we assume there are plenty of zeros before 4, okay, and that's how we move the decimal point 7 positions to the left. Okay, let's look at a couple of examples. Okay, how about this? You have a number and 10 to the power negative 2. So the decimal point will be moving to the left. How many positions? 2 positions, right? So the number is going to be 8. Is this right? A is the right answer. Here is another example. So the decimal point will move to where? To left. How many positions? 3 positions, right? So the right answer is B. Right answer is B. How about this one? 324 times 10 squared. Decimal point will move to the right. So the right answer is C. Because you assume there are zeros, right? On the right side. So it was right after 4, and then you move decimal point 2 positions to the right, assume there are 2 zeros on the right side. So the right answer is C. .931 10 to the 6. Move the decimal point 6 positions to the right. So the right answer is D, right? D. So the right answer is D. Okay, in the calculator, we sometimes write the scientific notation using E instead of 10. For an example, instead of writing 3.3 10 to the power 5, we write 3.3 E05. Okay, a lot of scientific calculators work like this, okay, just the basic ones. For an example, 5.8 times 10 to the power minus 1, instead of 10, we replace 10 by E basically. So we just write 5.8 E negative 0.1. So all of these are the same examples, how we write the number. So be careful, and if you have a calculator, scientific calculator, check whether you have EE or EXP and see whether you can find this notation and use it, okay? So make sure you understand how you use your calculator, okay? But because everybody might have different calculators, so check with your calculator whether you can use these ones in your calculator and see whether you can get the scientific notations right. Now the next thing is, after we have learned the scientific notations, there are some specific scientific notations which are called engineering notation. Okay. Now engineering notations is some of those 10 to the power, not all. Okay. And what we do is, instead of the engineering notation, we just use some engineering prefixes. Once we know the notation, these prefixes are letters, okay, or abbreviation of some terms like kilo, mega, milli, micro, those sort of things. But all the engineering notations come in as power increments of 3. Like 10 to the power starts from, let's say, 10 to the power 0, then 10 to the power 3, 10 to the power 6, 10 to the power 9, 10 to the power 12, and similarly to the negative side, 10 to the power negative 3, 10 to the power negative 6, 10 to the power negative 9, negative 12. So everything comes in terms of 3. I'm saying there is an increase of 3 or decrease of 3. Okay? So that means what? There is no engineering notation for 10 to the power 2. There is no engineering notation for 10 to the power 5 or 10 to the power 4 or 10 to the power 7, 10 to the power 8. You see what I'm saying? So those can be possible in the scientific notation, but whenever you convert it to engineering notation, you have to stick with any of these best suitable to your number. Okay? Now let's look at some in detail. So let's look at a little bit of, so in some calculator there should be an ENG key. So whenever you write a number, no matter you write a number as scientific notation or as a regular decimal number, if you press that ENG key, you should see the number as engineering notation. Okay? Or in other calculator, like the advanced one, TI series, you can change the number formatting as normal mode, scientific mode, or engineering mode. That's how you can get different notations or the basic ones. So for an example, let's say you have a number like this, 161 10 to the power 3 volts, let's say. So what we do is, instead of writing 10 to the power 3, we replace the 10 to the power 3 by a prefix. Now since this is 10 to the power 3, that means kilo, we just use K for kilo. So that K is a prefix. So it's a prefix to your unit. For an example, let's say this is a volt, which is a unit of voltage. Now instead of just writing the, in addition to write the unit, you will also write the prefix. So that prefix will replace the 10 to the power 3. So instead of writing 10 to the power 3, you can just write 161 kilovolt. So since you have written kilo, we know that there is a prefix. I'm saying there is a scientific notation which is 10 to the power 3 for it. Similarly for milli, you can write M. So let me show you the whole picture now. So here, this is the base, which is 10 to the power 0. But if you go to the power positive side, 10 to the power 3 is kilo, 10 to the power 6 is mega, 10 to the power 9 is giga, 12 is tera. To the negative side, 10 to the power negative 3 is milli, negative 6 is micro. This is a Greek symbol. In Greek that is called mu, but this is also used as micro. 10 to the power negative 9 is nano, 10 to the power negative 12 is pico. You might have to come to this slide and use this page a lot of times when you will be answering the quiz question. Okay? Or maybe you can just print this one single slide so that you will have the whole table or chart when you will be answering the engineering notation questions. Okay? So pretty much there are some hints. So 10 to the power 9 means nano, so that's why it is N in this, Also look at carefully what we use. Most of the cases we use small letters for the negative ones. For the positive ones we use capital letters. Kilo, widely used as a small k, but sometimes you use capital K, it depends. But the K doesn't have any confusion, but M has a huge confusion. Because the big M means mega, the small m means milli. So be careful about the cases. Okay, let's look at some examples. 23 times 10 to the power negative 6. Negative 6 is micro, right? So it should be 23 microamps. Right answer is B. This is what? 10 to the power 3, right? Which is kilo. So that is 23 kilo ohms. Right answer is D. 10 to the power negative 9. Negative 9 is what? Nano. So the right answer is A. You may look at the chart so that you can, this is the first time you are looking at it. So 13 10 to the power 6. 10 to the power 6 is what? Mega. So the right answer is E. 10 to the power 9, which is giga, right? So the right answer is B. Ten to the power 3. So the right answer is kilo. So 423 kilo amps. Ten to the power 6. So that is mega, right? So the right answer is M, capital M. Be careful, small m is milli. So right answer is E. Ten to the power -3, which is milli, right? So right answer is C, small m. That's 4 milliamps, right? 10 to the power 3, again kilo, which is K. Right answer is D. Ten to the power -6. So right answer is micro, which is B. Ten to the power -9. Which is nano, small n. Right answer is A. Ten to the power 9. So that is what? Giga, right? Capital G. Right answer is C. So let's look at how to convert a power of 10 to engineering prefix. Remember, all the power of 10 do not have the engineering prefix, right? For an example, for 10 to the power 2, there is no engineering prefix. So what you need to do is, if you have 10 to the power 2, you have to either make it 10 to the power 3, right, to get an engineering prefix, right? For an example, if you have a 10 to the power 5, what do? You may want to make it 10 to the power 6, or may want to 10 to the power 3. Because you have to either stick with any of those, right? And all those are like an increment of 3. So, and then you have to adjust the number in that manner. So that means if your exponent gets, again, if exponent gets smaller, so the number gets larger. Remember, that's always true, right? We did it before. If the number gets smaller, exponent gets larger. So you can always do it in the calculator, because if your calculator has different modes, change the mode and you get the number like that. But in other cases, you may want to just use the ENG, or in some cases it's shift ENG to get the decimal back. So check your calculator to see whether how you can get back to engineering prefix, or meaning you can, go back and forth between decimal and engineering prefix. So and for an example, let's say this is 10 to the power -5. So what we do is we adjust it to 10 to the power 3, because if you have 5, you can either stick with 6 or you can stick with 3. So we did it with 3. So what you need to do is, if you make it 3, your power is getting smaller, right? But the number will be getting bigger, because if the exponent get smaller, number get bigger. Or it's vice versa, right? So how many exponent you decrease? 2, right? So that means your number will be bigger, so your decimal point will be moving to the right direction, because if the decimal point moves to the right, number gets bigger, right? It was 3.3, now it becomes 330. But once you have it, you know that you have 3.3, 10 to the power 3. So now you replace 10 to the power 3 by kilo. We did the same here. Oh, we will show you the question. Yeah, we'll show you the question. So these are some examples at how you do that. But let's look at a couple of examples. Now, for an example, can we convert this following number to proper engineering notation? Meaning, you have milli. You want to make it micro. What do? So you are going downward, right? The power of 10 is what? Getting decreased, because milli is 10 to the negative 3 and micro is 10 to the negative 6. So the power is getting decreased. So number will be increased, right? How many positions you are increasing? 3 positions, right? So how do you make it 3 position increased? So the number is 0.23. To increase, you always move it to the right. So you have zeros in to the right side. You move it 3 positions to the right. So number becomes 230. So the right answer is B. Again, you are given something in terms of millivolt. You have to convert it to microvolt. Power is getting decreased, right? By 3. Since the power is getting decreased by 3, number will be getting increased. That means what? You move decimal point to the right. So 0.23 becomes 230. 3 positions to the right, right? Decimal point will be moved. So right answer is B here. Let's look at another example. 0.45 amps, meaning this is in base. There is no engineering prefix, that is the base. And you have to convert it to milli. Is the power getting decreased or increased? Milli is what? 10 to the power negative 3, right? Power is decreased, so the number will be increased, right? So number will become 450. So the right answer is A. This is 450 milliamps. How about this one? This is in base, and your power will be you are going to kilovolt. So the power is increased, right? Because this is base. That means the power is what? 10 to the 0. And you are making it 10 to the 3. Power is increased, so the number will be decreased, right? So that means the decimal point will move 3 positions to the left. That becomes 4.65. Right answer is D. Right answer is D. Another example. (2100 kilovolt). You are going from kilo to mega. So the power is getting increased. So the number will be decreased by 3. It will be 2.1. So the right answer is C. So that means it's getting 2.1 megavolt. 0.5 kilo to base. So the power is getting what? Decreased, right? Because the power is right now 10 to the 3, and you are making it just to base. So if the power is decreased, number will be what? Increased, right? So it becomes 500. 3 positions to the right. So remember, if you move to the right, the decimal point, the number gets bigger, right? So the right answer is D, A here. (1000 millivolt). If I say 1, what I'm doing? We are decreasing the number. So the power will be increased. So how many positions we decreased? We decreased 3 positions, right? So if you increase the power, that becomes base, right? Because this is milli, 10 to the negative 3. If you add 3 with the power, that becomes what? 10 to the 0. So that's just the volt. So A, no prefix because that's base. Right answer is A here. How about this one? You are increasing the number, right? You are increasing the number, so the prefix will be decreased. So the prefix is milli right now. It will become micro. Number gets bigger, prefix gets smaller, right? Milli is 10 to the 3. If you get decreased, it becomes 10 to the negative 6, which is micro. Right? The right answer is C. Is C right? Okay. Let's check another example. 6870 microvolt. You are writing 6.87. You are decreasing the number, right? So so the prefix will be increased. This is micro, meaning 10 to the negative 6. If you increase it, it will be 10 to the negative 3, which is milli, right? So the right answer is A. So now we'll show you how you add and subtract the powers of 10. Now, the most important part here is, if you add or subtract the power of 10, your exponent in the power of 10 must be same. So if they are not same, you have to make it same before you add. And then, once the exponents are same, you align the decimal point in a column and perform the math. You just have to add 2 decimal point, and then you will just write the number, and then you might want to adjust the answer to get into the proper scientific form or engineering notation. Okay? For an example, let's say you are adding 3.3 10 to the power 5 plus 4.7 10 to the power 4. But at this point you cannot add these because power of 10 is not same. To add it, we have to make the power of 10 same. Now, so we keep this one as it is and we adjust it to 10 to the power 5. So we pretty much made both of these 10 to the power 5 and adjust the decimal point. Now you can add the fraction, meaning you are adding 3.3 and 4.7, right? If you add those two, that becomes what? 8. So you basically will be adding only the fraction because power will remain same. So similar is all these examples, because what you need to do is, if the power are not same, you make the power same. It's 10 to the negative 5 and this is 10 to the negative 4. In the next line we made both as 10 to the negative 4 and we adjusted the fraction. And then you add the fraction. Let's say we added the fraction, we made it 7.06, 10 to the negative 4. But the problem is, there is no engineering prefix for the 10 to the negative 4, right? So we again went back to 10 to the negative 3, since the power is increased, right? -4 to -3 is increased, right? We increased it by 1. Since we increased, we moved the decimal point 1 positions to the right. I'm sorry, to the left. Because since the power is increased, we decrease the number. But now we know this is 10 to the -3, which is milli, right? So we wrote that, we add the prefix. So that becomes 0.706 milliamps. But instead of that, you could have written 706 microamps, because you can move decimal point 3 positions to the right and then change this milli to micro, right? Since the number is increased, unit will be decreased, right? Decrease means you are going downward to the table. Remember the table chart we have? Decrease means you are going to the downward. So if you multiply the exponents, you don't have to care about the power, because power can be different. Okay? So all you need to do is, you have to multiply the decimal numbers and also multiply the powers just by adding their exponents. Let me show you how you do that. For an example, let's say you are multiplying these two numbers. What you need to do is, you first have to multiply 3.3 and 47. If you multiply 3.3 and 47, you get 155.1. But for the exponent, we just add the power. Don't forget, if you multiply two 10 to the power exponents, if you multiply, power gets added. So pretty much that there was 2 power, right? 10 to the 5 and 10 to the 4. Look at this, we added the power, right? In case of multiplication, you add the power when you are multiplying the exponent. So at the end, you will have 155.1 10 to the 9. Similar is here, you multiply 10 to the power 5.8 and 6.48. You got this one, 37.584. Power get added. So that means -2, -1, you added the power. Even if you have units get multiplied. So for an example, there is inch and there is inch. So we assume there are power, right? Inch to the power 1, inch to the power 1, multiplied, that means their power is added. That become inch square. Inch and inch. We assume there are inch to the power 1 and inch to the power 1, right? So in case of engineering multiplication, you multiply everything. You even multiply the units. Inch and inch multiplied. So it's something like inch to the power 1 and inch to the power 1 multiplied, and their exponents get added. 1 plus 1. That becomes inch squared then. In case of division, you will still do the same thing. You divide the first decimal by the second one. But in case of power, since you are dividing the exponent, you will be subtracting the power instead of adding. Okay? So you subtract the later ones from the first one. For an example, here, let's say we divide 3.3 by 47. We get this one, right? And then the power is 10 to the power 5 here, and power is 10 to the power 4 here. Subtracted the power. You see, 5 minus 4. That becomes 10 to the power 1. Now if you get rid of this 10 to the power 1, you can go to the base, which becomes 0.702. Another example here, you are dividing 5.8 by 6.48, you get the fraction. You subtract the exponents, 10 to the power -2, 10 to the power -1. How you subtract? negative 2 minus negative 1, right? You are subtracting negative 1 from negative 2. How you subtract? You have negative 1, you subtract negative 1. That makes it 10 to the power negative 2. This 2 negative becomes positive. That becomes 10 to the power negative 1, right? And same is in case of unit. Look at the unit here. It's in inch to the power 3, inch to the power 1, right? Subtract the power. Last one from the first one. You get the inch square. Let's look at an example here. 6 kilovolt divided by 3 amps. Now remember, the volt by amps means ohm. So 6 kilovolt over 3 amps. So volt by ohms means ohm. I'm saying those are just units, but kilo will remain same, right? So that becomes 2 kilo ohm. So the right answer is D. Kilo is still remains same because that's the prefix, and that prefix is still remains same because you did not cancel or divide or add or multiply with anything with the kilo. I think this might be another one. Eight volt divided by 2 milliamps. What happens here? So 8 volt over 2 milliamps. Now remember, volt by m is again omega, right? Because those are unit, and those are coming from just like Ohm's law, right? I think most of you know the Ohm's law. If you don't know it, I think you will know it soon in the electric circuit class. So I just write V by A equals to ohm, so we don't care about that anymore. But let's look at the number here. So this is what, 8, and this is 2 10 to the power milli, right? Milli is what, 10 to the power negative 3. To make it easier, I just write 10 to the power 0 here, right? Because I can write 10 to the power 0 with anything, because that's 1. Now, I divide these two. 8 by 2 is what, 4? And for the exponent, I do what? Subtraction, right? This is a division. So 10 to the power 0 minus 3. You have omega here. That becomes 4 times 10 to the power plus 3, which makes it 4 kilo ohm. So the right answer is D. Let's look at another example here. I think this is simple, right? Because there is no prefix, that's only omega. So the right answer is B. Meaning 5 omega, 5 ohm. This symbol is called omega in Greek, because this is a Greek alphabet. But electrical engineering people, they also use it for the unit of resistance called ohm. Let's check this one. 9 kilovolt by 3 milliamps. Kilo by milli. That's the tricky part. 9 kilo divided by 3 milli, right? 9 kilo means what? These, and 3 milli, and then V by A means omega, right? Just write omega here, and then you divide 9 by 3, you get 3. But the power gets subtracted, right? So it will be what? 3 minus 3. That becomes 10 to the power 6. Because the negative makes it positive, right? Which is 10 mega ohm. So the right answer is A. Any question here? Let's look at another example. This time we are doing multiplication. 9 kilo times 3 milli. How do you do it? Kilo times milli. 9 kilo is this, right? 10 to the power 3 times 3 times 10 to the power milli, and that omega and ampere makes it volt, so you just write V. So we multiply 3 times 9 first, right? That makes it 27. But the power of 10, we are multiplying, right? Power of 10s get added. So how you add? Times 10 to the power 3 plus negative 3. That makes it 27 times 10 to the power 0. Okay, which is just base, right? So that means it's 27 volt. Because anything to the power 0 is 1, right? Right answer is D. Plus minus 3 is what? Minus 3. So 3 minus 3 is 0, right? So the right answer is only volt. So there is no engineering prefix. So right answer is D. Let's see whether you can understand this. Let me give a pause here and see whether you can do it. So you are multiplying 5 milli times 2 milli, right? And milli is what? 10 to the power negative 3. Okay, did you find the answer for this question? What is the answer? It's 10 what? Micro, because this is 10 to the power negative 3 and this is 10 to the power negative 3, and you are multiplying, right? So you are multiplying means what? You are basically adding their power. Negative 3 plus negative 3 is negative 6, which is micro. So the right answer is C. Let's look at the last example here. Kilo times kilo, right? 5 times 3 is 15, but the prefix is what? Kilo times kilo. Kilo means what? 10 to the power 3. So 10 to the power 3 plus 3. 10 to the power 6. That is mega, right? The right answer is A. It's mega volt. Now let's go to the quiz section and let's finish the quizzes for chapter 16, and make sure you also look at Successful Technician chapter 10 and 11. There is a lecture on that. I'm saying that's not a math lecture, so just let's look at that and there will be a bonus section. Okay? Let's go to the quiz section and finish the quizzes first for chapter 16.